Okay, I'm gonna now look at what? I'm gonna look at multiplication, because previously we looked at what? The binary operations of addition and subtraction. So now I want us to look at the multiplication. Right. So it's so easy. This is just a revision of actually addition. Let's take a number like 10111. We are going to multiply that with 1101. Okay, and then this is both what? If the numbers are not given as binary, this is binary arithmetic, so you probably be instructed to what? To convert your numbers. You won't be told. You'll be told do this application, what? This operation, what? In binary, and it's up to you now to remember that you have to what? You have to convert whatever is not in binary, convert it to binary, and then to the proceed to the multiplication. So what we'll do is we'll say the first number there, what we normally call our multiplicand is multiplied by 1101, and this we call it the multiplier. Now we say okay, so I prefer my work to be a little bit neater than that. So now every time when you've got a what? You've got a 1 on the multiplier, you load the multiplicand. Okay, so we have a 1 there, so we load the multiplicand. Now we've got a what? We've got a 0. All we do is what? All we do is load 0. How many bits of 0? As many bits as the what? As the multiplicand. So the multiplicand has got 2, 4, 5, 1, 2, 3, 4, and 5. Now the multiplier is a 1. We load the multiplicand. Now the multiplicand is what? Multiplier is a 1 again. We again load. Oh, what am I doing? That's not my multiplicand. I load the multiplicand. I either load the multiplicand as it is or load zeros according to whether the multiplier is a what? Is a 0 or a 1. So I load the multiplicand. All I do is add. Now this is a 1. These here, before I go there, these here are called partial products. I'll be referring to partial products, and I don't want people to be confused what we are referring to. So these are our partial products. Now we add the 1 on that column. There is only the 1, so there is our answer 1. That column there is only that 1, so there is our 1. That is 1 and 1, that is 2, so it's 1, 0. That there is 1, 2, 3, so it's 1, 1. That there is 1, 2, 3, 4, so 4 is 1, 0, 0. It's a 4, not 5. So it's a 1, 0, 0. So here it's only the 1. There is 1, 2, so it's 2. And then 1, 2 again, so it's 2. And that there would be our final product. Okay, this is our final product, or just our product. Okay, get the product for these two in binary, or they're already given in binary, which if you're lucky. Otherwise they're given a different base and you have to convert them to binary. And then all you do is what? Every time you've got a 1, you load the multiplicand. Every time you've got a 0, you load zeros. Every time you've got a 1. So I can't keep saying that. It's repetitive. So now let's suppose our question had commas. Let's say that was a comma and that was a comma. Do we change how we do things? No, we don't. All we do is at the end, what we do, we just count the total number of what? Total number of decimal places between the multiplier and the multiplicand. Our multiplicand has got 1, 2. Our multiplier is 1, 2, 3. Total of 2 and 3 is 5. We'll come to our final product and say 1, 2, 3, 4, 5. So that will be done via the what? the program would know at the end of the day. Just count the number of what, the total number of what, of decimal places, and put it on the what, on the final product. All right, so that is one example. Let's take a second example. I will take an example and say 1. I will take an example and say 1 1 0 1, and I multiply that with 1. Before I do that, this is okay. If the question said you get given you what, it give you new decimal places, all you do is what, place the what, place the total number of decimal places on the what, on your final answer. I think I said that already. So if we're given a question like this, multiply to 1 1 0 0, for instance, and all we'll do is say there is our what, there is our 1 1 0 1 is our multiplicand, and 1 1 0 0 is our multiplier. What do? We say it's a 0. The first digit is a 0, the LSD is a 0, so all you do is what, place your zeros, same number as what, as the multiplicand. Then the next one is also a 0. What do? You place zeros, same as your multiplicand. Okay, this one is a 1. What do? You repeat the multiplicand. This one is a 1. You repeat the multiplicand. Okay, then all you do ultimately is get the total. That's a 0, so 0. That's a 0 0. That's a 1 1. That's a 1 1. That's a 1 1. That's what? That's 2. And that's a what? That's a 2. So ultimately we have that is our what? Is our final answer. So what we'll then do is say, okay, we have, if do we have decimal places or not? If we had decimal places, let's suppose there was a comma and probably there is a comma, then what we'll do is we'll then say there's 1 2 3 4 5 decimal places, 1 2 3 4 5 decimal places in the what, in the final answer. Now this is my problem. I wouldn't want to illustrate with such a stupid example, because now this here is what, is 0, so this would have been unnecessary to have made this whole exercise here a little bit different. I wouldn't have multiplied with zeros there if there was what, if there was only one decimal place. This is actually one decimal place, but obviously what it would have meant is that you have 1 2 3 decimal places. If you ignore these two because they're actually redundant, it's 1 2 3 decimal places. So our answer is still fine. So I just don't want to look like someone doesn't know what they're doing. So probably I would prefer to ignore the decimal places and say probably I wouldn't mind probably having this, because then you are going to have 1 2 decimal places. But then of course that would eliminate the decimal places, because this number, then it means these two are now redundant. These two zeros are now redundant. But in any event, what I wanted to portray here, what I wanted to show was the process. So I hope that we are happy with the process. So if this was our question, this is our answer. Now let's use this example to show how the computer would work. How does the computer do it? How does I would like to say old computer do it? Well, I'm not too sure whether the new computers will still be doing this. I would have to look into it. How does the computer do it? Okay, I probably think it will still be the same. Right. So the computer is given two numbers. So the number is, let's say 1 there. We say we are multiplying what? Our initial number is 1 1 0 1 in binary. The second one is 1 1 0 0. This here is, we are loading. Okay, let me give myself space to explain some. Let me give myself space. I will explain. Probably not that far. Let me have where my numbers end. I should probably have taken some that was gonna give me thing, but I know it's fine because I'm trying to have instruments that will give me straight lines. I really wonder whether that would work. No, I don't want that. Okay, I will come back to that. I'm still trying to figure out my software as well. Everyone learns every day. This software is new for me, so I'll try to be as straight as I can to save time. So now, this step here will be step 1. We'll probably load this in some register. Load in some register what the multiplicand. Then here we would load multiplier in a different register, in other register. So what we then do is number 3. Now we say, okay, now we're multiplying. These are the two numbers we're multiplying. What do we say? We say, okay, what is the first bit? First bit, or ls, what we call least significant digit of multiplier is 0. So what do? We load. What we're doing basically is we're doing this. We load F. There's 4 zeros, so we load 0. So what we do is we load zeros. 1, 2, 3, 4. Okay, so we load zeros. Same as what? Same number as what? As the multiplicand. So we've loaded our 4 zeros. Our multiplicand is 4. We've loaded 4. All right. So we load zeros. Then now what do we do? Step 4. We shift 1, 2, 3. Instead of going that way, we actually go the opposite way. We want to shift this number this way, so we shift this one space to the right. So shift 1, shift to the right. We're only shifting one space at a time, so shift to the right. All right, so once we've done that, step 5, we look at the second what? At the second bit. The second bit is zeros. What do? You load. So you repeat second bit of multiplier is another 0. So what do? You load. Every time it's what? Zeros. Every time the multiplier is a 0, you load zeros. So you load zeros. Step 6, because addition, when you add, we could have done our addition right there and had a stream of zeros. So what do? You add. When you add is 1, 2, 3, 4, 5. If we added at that point there, we're going to have 1, 2, 3, 4, 5. So you load and then you added 5. So add 4 to the content of 4 to the content of 5. All right. So then what do you do next? You shift 1, 2, 3, because you want to work with the next bit. So you shift you are shifting. This guy comes here, that guy comes there, that one comes there, that comes there, that comes there. So you shift. Always when you shift one bit. I should have said one bit. One bit. I want to say I bit, so say one bit. Shift one bit to the right. Okay. Now, what you then do? Step 8. You look at the next bit. The next bit is the one. So you load multiplicand. Your multiplicand is 1, 1, 0, 1. What do you do? Third bit is 1, load multiplicand. So when it was a 1, we loaded the multiplicand. So what you do? Step 9, you are going to add 1 plus nothing, 1, 1 plus 0, 1, 0 plus 0, 0, 1 plus 0, 0. Then, what am I saying? 1 plus 0, where do I come from? 1 plus 0, 1, 0 plus 0, no, 0 plus nothing, 0. Remember adding 7 and 8 and 0. So, what we do? We add contents of, what call this? Contents of 7 to 8. Contents of 8. Okay, so now after we perform, we shift one bit. This is step 10. We shift one bit. This bit comes there. Bit 4 becomes bit 3. Bit 3 becomes bit 2. Bit 2 becomes bit 1. Bit 1 jumps the line. These two bits shift to the right. So shift one bit to the right. Now 11, you check the next. After we shifting, we look at the next, the bit of the what? Multiplier. It's a 1. We load 1, 1, 0, 1. So we load, this is the fourth bit, fourth bit of multiplier is 1. So load multiplicand. Okay, so we loaded the multiplicand. There is our multiplicand. So after we load, what do we do next step? We carefully, okay, we add 10 and 11. Add 10 and 11. The content of 10 to 11, that is a 1. Okay, that won't be a 1. That will be a, let me start this side here. 0, 0, 1, 1, 1. That would be 0, 1. So this is not a 1 because it's a 0. It's a 0, 1. Okay, so now what you do when you're done with that, once you've done your final addition, you probably shift, but there's nothing more that is left. So that what you have at this point here is what is your answer. This is already your answer. You could shift it to the but it don't, because if your register can only take that much, after adding you would shift, but then it's not really important, because if you look at this answer, that there is the same as that 1001 1001 1100 1100. So that there is our final answer. So I'm trying to explain how the computer, basically there will be a program that will be there will be a program that will say this. Okay, it will say check if you what, check if your bit is a 0. If it's a 0, load zeros. Check if it's a 1. If it's a 1, load multiplicand. After that, add. Check if it's a 0, load zeros. If check if it's a 1, if it's a 1, load multiplicand. Oh, by the way, you shift first, shift, add, shift. So it keeps doing the same thing. You check if the bit is a 0 or 1, you load zeros. After you load the zeros, every time you load, what you do, you can add and then what call this and shift according to where you are. If I'm here, the first thing I did was shift. After shifting, I check the next bit. If a thing, if it's a 0, if it's a set of zeros again, what do? I add, because I could have, what I'm saying is, I could have first added right there. Okay, the first two partial products I could have added. After added, then I would have shifted. After shifting, I check my bit. It's a 1. I load, what do you call this, the multiplicand. After loading the multiplicand, what do? I add. After adding, I shift. Check the next bit. If it's a 1, I load the multiplicand. It was a 1 in this case. I load the multiplicand. What do? After I load the multiplicand, I add. After adding, I shift. That's basically how the computer does this. It's basically a program that we got that would basically assist. Once the program has been written, all you do is add the numbers, hit your time sign, and then the program will run, and it will know when to add what, when to load what, when to shift. Obviously, what you need to do, what is needed, you need an adder to do the adding when it's time to add. You need a shift register for you to to be able to shift. This one is specifically a right shift. Okay, right shift. Okay, obviously, what else do you need? You would need also what goes the stores, the registers, or registers. All right, that's basically how that's basically how you do the multiplication, and that's also how the computer does it. All right, so thank you. I hope you understood. It might have been a little tricky. Depending on what level you do, probably your syllabus might only require you to know how to do the multiplication yourself. But depending on, like I said, depending on what you are doing, you may also be required to be able to to explain how a computer would this was just an example. They'll probably give you their own example and say, explain how the computer would actually achieve this. All right, thank you so much. I hope that was useful. Let's meet again when you do the division, and hopefully showing you how the divider itself works. Thank you. Salute.